Hi everyone, this is Michael from Brevis. Today I'm going to talk about how you can build next generation dApps with ZK coprocessor. But before I dive into what is a ZK coprocessor, let me give a quick recap on blockchain design history. Blockchain design has always been a trade-off game. So when we're designing layer 2, layer 1 blockchains, security, decentralization, and performance is the very famous blockchain design trilemma, where you can achieve at most two and sacrifice the other, to build a layer one blockchain. Different blockchains choose to operate at different trade-off points. And for example, Ethereum here operates at high security, high decentralization, but pretty low performance. So, people have been thinking about how we can break this kind of initial triangle of trade-off space. Um, the solution, of course, is layer 2 rollup. So for layer 2 rollup, you get similar security as layer 1 blockchain, pretty good decentralization, and much higher performance. However, you're not getting all of these three for free. What is being traded off here is unity. What I mean by that is if you look at all these layer 2 blockchain ecosystems today, we have so many of them, right? So, what we end up is liquidity, state, and user fragmentation. You have different applications with similar purposes all exist on different layer 2 blockchains, and user has to use very high friction methods to move between these enclosed blockchain ecosystems. So they are more like isolated islands. The performance is definitely better, but it's still fundamentally limited by a monolithic computing model where you have a one single thread machine that is like operating as a blockchain. And it is not possible to do computation that is even faster than a single server. Let me give you an example of the poor performance of the computation today. So, if you look at many of the centralized exchanges, a trader loyalty program is something that every one of them has. So it works like this. For a loyal trader, if this trader traded a certain level of volume in the last 30 days, in the next 30 days, he will be granted with a VIP trader status and with a reduced trading fee. This feature works really well to retain loyal traders and generate higher volume and also revenue for centralized exchanges. But if you look at every single DEXs, that is like operating today, none of them has that feature. Well, why is that? Turns out that building this feature directly on the blockchain in smart contract is extremely expensive because it involves a large amount of computation of Merkle inclusion proof. So even on the cheapest layer 2 blockchains, it still takes 8 hours and 40K in transaction fee to just compute the trading volume of 10,000 trades for a single user in the last 30 days. So it basically means that to build any kind of data-driven and complex computation features on blockchain today is not possible. So how do we solve that? Well, fortunately, history rhymes here. We actually solved a similar challenge during the Web 2 scaling process. So Web 2 before 2000 was really built on a synchronous architecture, where the web server handles everything as a single thread server. From request handling, access control, computation, data access, it handles user requests one at a time. And it was very clear this type of monolithic architecture does not scale. So, over the last 20 years, the entire Web 2 world has evolved into this modern web architecture with glue and coprocessors. So web server now act as a coordination point to receive users' requests with high concurrency, and then turn around and issue asynchronous calls, essentially messages, to specialized back-end coprocessors such as big data services, AI services, database services, authentication, and all of that. So these specialized coprocessors will perform these computation, at its best, and then, relay the result back to the web server as callback functions. Web servers will receive these callbacks and then assemble them and deliver the final assembled result back to the user. So as you can see in this architecture, web server is no longer the bottleneck. It is a glue that can command and operate across a variety of backend services to increase the computation capacity to a theoretical infinite level. So if you look at Web3 today, we are actually at a spot that is worse than Web 2 before 2000. It is still very much a synchronous architecture because we're essentially operating on a blockchain with a single threaded computing server. What's worse here is that the blockchain is actually rooted in replicated compute and replicated storage with huge communication overhead for the consensus protocol that every single blockchain is based on. So what Brevis is trying to do here is Brevis is trying to introduce this new paradigm of smart off-chain verifiable computing, where we can treat the blockchain as a glue to offload very complex computation to a very low-cost off-chain environment. And in this off-chain environment, you can generate not only just the computation result, but also a ZK proof of the computation. It is very important to note that the reason we want to generate the ZK proof is that because we can submit the ZK proof back to the blockchain, so that blockchain can verify the proof easily and cheaply on-chain directly. That's the magical power about ZK. No matter how complex the original computation is, once you compute a ZK proof of the computation process, you can verify the proof with extremely low computation cost. Now, because blockchain can verify the proof, so it can actually consume the result directly, as if the entire computation happened on blockchain directly. So this architecture enables the blockchain to become just the glue point of verifiable computation resources. This really brings blockchain scalability to another level because it allows blockchain to tap into off-chain computation resources in a parallel way. It is no longer constrained by a single server. You can actually offload computation that involves with AI inference, data computation at the same time and receive result in a concurrent way. So, we were talking about complex and data-heavy computation. What exactly is the computation we target initially? Well, right now, Brevis's flagship product is a ZK data coprocessor that enables smart contracts to generate ZK proof of arbitrary computation on any historical on-chain data, such as states, transactions, and events, and allows the smart contracts to utilize these computation results on-chain in a fully trust-free way, as if the computation is done on the blockchain directly. So Brevis comes with a full-fledged and smart SDK, so that you as the developer don't need to worry about anything related to building a ZK circuit or understanding how ZK works on the line. Using Brevis is very simple with 3 steps. First, you specify what kind of historical data you want to read, such as transactions, what is like users trade on this DEX, if there's any liquidation event that happened on this Lightning protocols, or storage state, who hold this NFT in the past, what is the average balance of this user's holding for a certain token, and so on and so forth. And then, after you specify what kind of data you want to read, you can specify the computation logic. This is where the business logic lives. Things like calculating what is the trading volume of a particular user is calculated here. We offer a very easy to use data stream API where you can do map, reduce, filter, group by, sort, zip, and all sorts of like basic computations to manipulate on this data stream of data. And finally, with the computation result, generated, a ZK proof will be also generated and sent back to the blockchain, where a verifier contract will verify the proof. Once it is verified, the computation result will be delivered to your smart contract so that you can utilize that directly in your on-chain business logic. So just to do a quick comparison, to build the same trader loyalty program with Brevis, for example, if you're approving 10,000 trades for a user on Uniswap and calculate what is a trading volume, like you're not only just calculating volume, but you're actually also attesting to the fact that user actually made these money trades. The cost is only 24 cents, and the latency to generate such proof is only 50 seconds. So, with Brevis, you can actually allow a smart contract to tap into these kind of data insights and do the computation that was not possible before. So there are a lot of the different top projects utilizing Brevis today. Broadly speaking, there are three main categories of use cases that we see people are using Brevis for. The first is intelligent DeFi. The idea of intelligent DeFi is that you can actually, dynamically tune and adjust the DeFi protocol's parameter based on a historical data available. For example, you can actually see what is a user trading volume or what is the market volatility and dynamically adjust the pool fees or user trading fee directly. For example, we have launched this kind of a feature with Quanta, which has witnessed like 5 times growth in the trading volume for the VIP trader rebate enabled pool. We also work with projects like Jojo to make entire perpetual swaps risk model in a trust-free fashion. There are also use cases such as active liquidity management, where you can trust-freely rebalance the liquidity across multiple different DEXs and lending pools based on on-chain historical data insights, so that you can actually build fully trust-free on-chain hash fund using Brevis as well. Not only in DeFi, but we also have a lot of use cases in consumer adoptions. For example, we work with a rising star in the stable token space called Euro. And, to launch something called continuous protocol incentivization. This is very different from like this one-off airdrop that is quite common in our industry today. Continuous protocol incentivization allows users to align their interests in a long term with the protocol and projects, because it allows users to generate ZK proof of their ongoing interaction with the protocol, and then use that data to generate a numerical score so that it can directly claim a token emission in a fully trust-free way. So this is so much better than one-off airdrop, because for one-off airdrop, the entire process is really a black box. It is not transparent for the users and often causes frustration. It is also a major cost center for projects. But with this, everything is transparent, and it's much more powerful than simple liquidity farming, because you're not just only recording liquidity, you're also just generating proof for the user's historical interaction and behavior in the protocol itself. We also work with many infrastructure level projects, such as Zero Gravity for their cross-chain data availability use cases, Bedrock for their cross-chain Bitcoin restaking functionality as well. So, with that, hopefully you have a better understanding of what Brevis does. And we are very much open to hear your feedback. And if you are interested in building with Brevis, we are always open and available for questions. Thank you.